Hi everybody. In this video, I'm going to go through lesson 2.02, measure length. All right, so in this lesson, we are going to be using what is known as the segment addition postulate or the segment addition property. Let me move this real quick. That's in the way. Okay. Segment addition property. And the segment addition property basically tells us if we have a segment with two endpoints, maybe our endpoints are A and C, and we have some other point on the segment, this is point B, we know if the segment from A to B is 3 units, and the segment from B to C is 7 units, so if AB is 3 units and BC is 7, I can find the length of the entire segment AC by adding 3 plus 7, which gives us 10. So here I know that segments AB plus BC adds together to give us the length AC. And you might be noticing I'm not drawing the little segment bars above, and that is because I am referring to the distance. I'm referring to the distance that AB stretches added on to the distance that BC stretches, and that is equal to the distance that AC stretches. If I see AB just like that, that is referring to just the segment in space, and the properties that it might have and what's going on with it. That doesn't necessarily have to do with its distance. If I'm talking about the actual measure of that segment, I do not include the bar over the top. So we can add parts of a segment together to get the entire segment's length, which hopefully is pretty intuitive. Okay, so let's look at some examples. So example number 1, point Q is on segment QR. Nope, PR. Given PQ, so the measure of PQ is 5, and the measure of QR, so QR is equal to 13, find the length weird H. Find the length of PR, of segment PR. So we know the distance PQ is 5 and the distance of QR is 13, and we want to find the entire segment. Essentially, I want to know PR is equal to what? What's the distance of PR? I don't know how you could do this without drawing a picture. I really don't. I always think that's the best way to go here. We know that point Q is on a segment PR. So let's start by drawing a segment PR. So here's P and here's R, and I'm gonna place point Q on there somewhere. It tells us that PQ is 5. So the distance from P to Q is 5. And the distance from Q to R is 13. So QR is equal to 13. We want to know what is the entire distance from P to R. What's the length of segment PR? So in order to do this, I know that PQ plus QR will add together to give us the entire segment length of PR. So I am simply going to add up PQ, which is 5, plus QR, which is 13, to get that our segment PR in total is 18 units long. So PR measures 18 units. It's 18 units long. Let's look at another example. Point H, excuse me, is on segment GI. Given GH is equal to 3 and GI is equal to 12, find the length of HI. Find the length of segment HI. All right. So again, want to draw a picture for this. Point H is on segment GI. So I'm going to draw our segment GI with point H on there. They tell us that GH is 3. So the length from G to H is 3. And then they tell us GI is 12. Now, GI, that's the entire thing. That's the entire segment from G all the way to I. So GI is 12. So if I want to find the length of segment HI, that is this unknown distance here, right? From H to I. And well, we know GH is 3. And we know that if we add GH plus whatever HI is, it's going to add together to give us GI. So with that in mind, if I know GH is 3 plus HI, I can take 3 and add on whatever the length of HI is to get GI, which is 12. So really, if I want to find whatever this length is, HI, hopefully you recognize we can just subtract 12 minus 3 to get this length, which is 9. So we can subtract here. This length HI, oh, it's gray. This length HI can be found by taking the entire segment GI and subtracting away the piece we don't want, GH. So you can also subtract segments as well. All right, let's look at another example. Point K is on segment JL. Given JK, segment JK is equal to 2x. Segment JL has a length of 4x. And segment KL equals 4x minus 10. Oops, I didn't mean to put the bar over this because this is a distance. So KL is equal to 4x minus 10. So given JK equals 2x, JL equals 4x, and KL equals 4x minus 10, we want to determine the numerical distance, length, sorry, same thing, but numerical length of segment KL. All right, definitely need a picture for this one. So here is our segment. The entire segment is JL. So here's J and here's L, and we know K is somewhere on there. Now, JK, segment JK is 2x. So this is 2x. Segment JL, it says, is 4x. Now that's the entire thing. So the entire thing is equal to 4x, and KL is equal to 4x minus 10. So I know that segment JK, right? This one segment I can take and add to segment KL, and that is going to give me the entire length of the segment JL. We know that JK is 2x, so segment JK is 2x plus segment KL is 4x minus 10. So I'm going to add on 4x minus 10, and that is equal to JL, which is 4x. So JL is 4x, KL is 4x minus 10, and JK is 2x. So substituting in what we know using that addition property for segments. And now I can simply, and I kind of went too far, I can simply combine some like terms here. I notice I have a 2x and a 4x, which combines together to give me 6x minus that 10, can't combine with anything, and that is equal to 4x. To solve for x, because this problem is asking for the length of KL, and right now, all I know is that KL is equal to 4x minus 10. So I need to know what is x. So I'm going to solve for x by getting x to one side of my equation. So in order to do this, I will subtract 6x from both sides. And I'll show you why I did 6x and not 4x in just a second. So that way the 6x's cancel and this 10x is all, or sorry, not 10x, this negative 10 is all by itself. And that is equal to 4x minus 6x, which is negative 2x. And now I have the variable on one side of my equal sign, so I can divide both sides by negative 2. So our negative 2's will cancel on the right, and I will get 5 is equal to x. So I now know that x is equal to 5, or 5 is equal to x, so where I see x in segment length KL, I can substitute in 5. So I have 4 times x, or 4 times 5 minus 10. And using the order of operations, 4 times 5 is 20, minus 10 gives me 10. So KL has a length of 10. I could also use x. We know x is 5. I could find the length of JK. I could find the length of the entire segment. All right, I have one more example I want to look at. Point M is the midpoint of YZ, segment YZ. Ooh, ooh. If YM has a length of 6x plus 6, and MZ has a length of 7x plus 9, find the numerical length of MZ. So we want to find the length of segment MZ. So M is the midpoint of a segment YZ. So here's my segment with points Y and Z, and the midpoint is the dead middle, right? So here's my midpoint M. Now, a midpoint always divides the section into two even halves, right? So this half, YM, segment YM, is the same length as segment MZ. They have to be the same. This also means the entire segment YZ can be found by taking one of the halves, so maybe YM, and multiplying it by 2. Or taking, and this is a Z here, YZ could also be found by taking 2 times MZ. So I could do either of the sections or either of the segments, YM or MZ, multiply it by 2 to get the entire length of the segment. So midpoints have a lot of interesting properties. So I know, and I'm just gonna get rid of this stuff, that the segment length YM has to be the same length as MZ, and we know YM is 6x plus 6, and we know that MZ is 7x plus 9, and those two segments have to be equal to each other. So YM is 6x plus 6, and MZ is 7x plus 9. And now my goal is to find the numerical length of MZ. And right now, all I know is that MZ is equal to 7x plus 9. So if I want the numerical length, I need to know what x is equal to. So I'm going to have to solve this equation for x that I have over here on the right. So solving this for x, I want to get x on one side. So I am going to, let's see, I'm going to subtract 7x from both sides. I could also subtract 6x from both sides. So 6x minus 7x is negative 1x. And then I have this plus 6. So negative 1x plus 6 is equal to the negative 7x and positive 7x cancel. So we're left with just 9. And now to get x all by itself, I can subtract 6 from both sides of the equal sign. So I get negative 1x is equal to 3. And now to get x all by itself, I will divide both sides by negative 1. So x here has to be negative 3. And if I substitute in negative 3 for x, I have 7 times negative 3 plus 9. 7 times negative 3. Uh-oh, I messed up somewhere. Where did I mess up? This shouldn't be a negative number. I'm not sure where my error went, where my error was. But I think when I wrote the problem down, yeah, when I wrote the problem down, this was supposed to be a minus 9. Because the issue here I'm noticing is I'm about to multiply. 7 times negative 3 is negative 21. Plus 9 is still a negative number. And we can't have negative distance. So I'm guessing this was supposed to be 7x minus 9. And let's see what happens when I make that change. So 7x minus 9, 7x minus 9. And then this would be a negative 9 here. So negative 9 minus 6 is a negative 15. That's what it is. So x is negative 15, which we would divide by negative 1 on both sides to get positive 15 as our x value. So x here has to be 15. My bad. And then using the order of operations here, substituting in 15 for x, 7 times 15 gives us 105. plus 9 gives us 114 as our length of MZ. All right, please let me know what questions you have on this section, and remember, practice always makes perfect with this.